Okay, this is a quick video on compound interest. A couple of things that you need to do to make sure that you understand what's going on with this is to, first things first, make sure you have this formula for compounded interest. It looks a lot like our growth and decay formula, specifically our growth formula, but we have this denominator n and this coefficient n up here, the exponent, that has now showed up, and it has to do with our compounded interest when it's being compounded more regularly than once a year. So when it says compounded semi-annually, which would be twice a year, or monthly, which would be 12 times a year, or quarterly, which would be 4 times a year, something like that, that indicates that you're gonna compound the interest more than once a year. So that being said, this formula helps us account for that. So if you'll pause your screen real quick and write down your formula, make sure that you can use that. Again, that n represents the number of times the interest is compounded per year. So once you have that formula down, I'll do a couple of examples with you just to make sure that you know what's going on. Okay, so we're going to do number one here from this example, where it talks about a 3-year investment of $20,000 with a 5.2 interest rate compounded semi-annually. Okay, so semi-annually, and our answer that we're supposed to get is $23,329.97. So that'll kind of keep us honest, making sure that we're doing everything right. So just to make sure we set this up correctly, our initial amount is $20,000. It's going to go in there for C. The rate is 5.2%, which means we have to turn that into 0.052 for our rate. And then the number of years is going to be T, and that'll be 3. It says right here, semi-annually. Semi-annually means twice a year. Semi-annually means twice a year. So that means that my n is going to be 2 for this problem. Semi-annually means that I'm going to compound the interest twice per year. All right, here we go. So let's go ahead and put all this into motion. All right, we're investing $20,000 at a rate of 0.052%. So 1 plus 0.052, and then we're going to do that semi-annually, so that's why I'm dividing by 2 there. And then n times t, there's my same n value, and it said it was a 3-year investment, and there I go. So this is the accounting for compounded interest semi-annually, which is twice a year. So now I could just type that in my calculator and get the answer. That would be my setup. So just grab your calculator and type that in, and you should see that this will yield this answer right here, $23,329.97. Just a couple of calculator tips. If I was you, I would pay very close attention to where you type these in. It might be in your best interest to figure out what this common ratio is, everything that's in that parentheses. Go ahead and figure out what that number is so that you could just type it in as a decimal instead of this whole expression. Also, when you go to type in your calculator, go ahead and multiply 2 times 3 and get 6 to help you out with that. All right, now we're going to go ahead and try another example just to see if we can keep with the vocabulary. So that was a semi-annually compounded problem. Let's see if we could do a monthly problem. So something kind of like number 3 here, where we're going to invest $190. That'll be our C value, or our initial amount, $190. Our rate is going to be 0.11 because I changed that to a decimal from 11%. And then it says compounded monthly, so that means there are 12 months in a year, so my n value is going to be 12. There are 12 months in a year, so my n value is 12. And then it says for 1 2/3 years. So that's a t value of 1 2/3. Well, right away, I'd love for you to recognize that that was 5/3 as an improper fraction, or if you turn that into a decimal, that's okay with me. Just know that every time you round, you're going to have a less accurate answer. All right, so we're going to plug all those into our formula. So here we go. Y equals $190 times 1 plus 0.11 over 12. Again, monthly would mean 12 months in a year. And then that same in value of 12 times 5/3 for 1 2/3 years. So I could type all that into my calculator and I will find that I will get the same answer as they did, $228.04. Again, tips as far as calculators is concerned, I would go ahead and figure out what each of these things are before I typed it all into the calculator at one time, just to be safe. All right, next what I'd like to do is do a compounded continuously problem with you. So real quick, I'm going to move to our compound interest compounded continuously scenario, and that's going to be a little bit different formula. So what that is our PERT, or principal times e to the rate times time power. Now, interesting enough, P is the same thing as our initial amount. So P stands for principal, but specifically it's our initial principal. It's the starting amount, okay? R is still your rate of growth, and T is still time in years. But then we got a new arrival, and it's this guy, this E. Now, E is not a variable. Let me repeat that. E is not a variable. E is a naturally occurring number, kind of like pi, that every single one of these compound interest, continually compounded interest problems have in common. They all have that naturally occurring ratio. It's an irrational number. It can be found on your calculator. It's a lot of times you'll need your second function to use it. It's the e to the x button. And again, it's kind of like pi, irrational number that every single continuously compounded interest problem has in common. That ratio they all have in common. So we're going to use that whenever they use the word compounded continuously. Again, in this scenario right here, this phrase, compounded continuously, is what then sends that formula into your head. Okay, so we're going to do that example together, but I just wanted to make sure if you need to go ahead and pause your screen, go ahead and do that. Write down this formula and make sure you understand that we use this PERT formula when we are compounding interest continuously. So never stopping, just constantly doing it. All right, here we go. We're going to do the full example together. So let me clear out some space here so that we can now go to work. Okay, we're going to do example 3 in an effort to do a good, I guess, showing of how to make this work. Okay, so 2,658 is going to be my principal, or my initial amount of money. So 2,658 times, and that's going to be automatically an E. So again, that's not a variable, that's a number that's automatically there. So in your calculator, once you go ahead and type E, it'll give you that number and then give you the ability to raise it to a power. So then that's going to be raised to the rate times time power. So in this case, 9%, or 0.09 is our rate. And then they said 15 years is how long they want to see this thing work in the bank and see how much we have left for our retirement. So that's what my setup should be. Again, 0.09 times 15 is an exponent. So what you need to make sure you do there is type that in either with an extra set of parentheses around those exponents, or go ahead and multiply what 0.09 times 15 is, so that that is the number that you type into your calculator. So I'm going to go ahead and type this in my calculator now. 2,658, and then second function to get my E onto my calculator screen. And then now I'm going to go ahead and type in 0.09 times 15, and that should give me $10,253.04. And that, again, is how we're going to do this. Our setup, again, is from that PERT formula. Make sure that you're using your calculator to find E and anything that requires E to solve.